Now recording is in progress. Yes, Kazim, you may read now. Sorry for
Okay.
interrupting.
As a project manager, you are tasked with implementing a new inventory management system. Within organization, you have decided to utilize historical data to improve the forecasting of future demand and optimize stock stock levels. Which of the following tools would not require use of historical data for accurate forecasting and optimization? Monte Carlo spread analysis, time history analysis, sensitivity analysis. Which
Kazim, your voice is not
tool
that clear
would
that
not
it used to
require?
be. What is the problem with your phone? Or,
Sarmal,
yeah, your voice is far away, and I am barely able to hear you.
sir, with issue I usually use my mother's mobile because my mobile don't have uh, any points for headphones.
Okay, so actually, it is quite better now. I can. Okay, you can continue reading the options.
Okay, Monte Carlo analysis, trend analysis, time series analysis, sensitivity analysis. So the answer question is on the negative side, like which would not require, right?
Yeah. So three of the following options will require you to look back at the historical information. I mean, your data should be about historical information, which you are feeding to this statistical model. So all of these are statistical model, by the way. So what do I mean by
Mhm.
statistical model? That model will accept some input or various inputs, and it will give us some output. Okay. So if we are talking about Monte Carlo, okay. So Monte Carlo technique, we read it in the quantitative risk analysis when we want to quantify, let's say we want to understand the probability and impact, and we want to quantify the probability and impact of certain risk event, and we are not happy or we are not content with the general description of very high risk or very low risk or very medium risk. So we want to know that if it impacts us, then what are the chances that we will be hit, okay, by, let's say, certain dollar amount, or let's say certain schedule delay, or if we miss certain part of the scope. So we want to quantify it. So we do this analysis, which is done through pushing the data about all type of risks that our end goal has. Okay, let's say that the end goal is that you want to make sure that you complete the project within certain number of days or certain number of months. Okay, and then you don't know the confidence interval, that how confident are you that you would be able to finish it in 10 days, 20 days, whatever is the duration of the project. So if you run all those risks through Monte Carlo analysis, the end date, the confidence interval, you would be able to get the confidence interval around the end date. You will be able to get, let's say, that you will be getting the data will tell, I mean, you will be getting the output which will tell you that 80 to 90% of the chances are that you will be finished within your desired duration, let's say 18 days. So you will be getting some confidence interval that there are 80 to 90% chances that you will be able to make it in 18 days. Okay. But you would not reach to this confidence interval without using the statistical model. So Monte Carlo does need an input which is based on uh, historical information. So if your risks has risk events, um, there is a risk around the estimates, okay, for activities, and all the activities have, let's say, pessimist duration, optimist duration, most likely duration. So there is a lot of variance around that what could happen with this activity. Can it be done in 2 days? Can it be done in 10 days? So each of the activity has so much variance, which means that there is a risk involved, because that's why there is a variance that, okay, one person is telling it may be done in 2 days. The other person is telling it may be done in 10 days. So why? Someone is so pessimist, someone is so optimist. There should be some justification. This because there is uncertainty. So when there is uncertainty to the estimates, take all these estimates and pass these through Monte Carlo analysis. It will do summation, it will do some permutation, and it will give you some uh, result. So it will tell you what is the combined impact of all these risk events on your outcome. So let's say all these inputs, like let's say there are 10 activities to the simulation model, and 10 activities, let's say we are saying, okay, all these activities can be done on a pessimist day. Let's say pessimist estimate, let's say each one will take maximum amount of time. Then the model will tell you what will happen with the end date of the project. One result it will tell you like that. If you will feed for all these activities, if you will be feeding to the model that all these activities should be done on the optimist day, then the model will give you another date. And then if you are feeding for all these activities, you are feeding most likely date, then the model will give you some other date. So the the, the flexibility for you will always be there. uh, the flexibility will always be there with you, that how you feed the data to the model. I would like you to watch this 2 minutes video about Monte Carlo simulation. That will make it more clearer for you. What do you think? Would you like to watch?
Yeah,
Yes.
sure.
Okay, let me share my screen, and I will be sharing it when we will have the video available. Just give me a minute. Hi Asip, how are you? Welcome to the class.
I'm good. How are you? Thank you so much.
Just asking the classes can we use Google Meet for the class?
Who is this? Kazim?
Ji sir.
What happened, Kazim?
I'm asking can we use Google Meet for having these classes?
We'll try. We'll try someday. Okay.
Okay.
We'll try it someday. Okay, Kazim?
Sure,
Can't
sir.
do it
Thank you.
now, but we will do it. Mm,